Hey there, it's Jason Gorman from Codemanship with a video all about continuous integration and continuous delivery in Python. Now, continuous integration is a term that you've very probably heard. You may well think that you're doing it as well. We'll soon find out. First of all, we're going to talk about what continuous integration is, and then we're going to do a little demonstration, and then we're going to talk about the whole wider process of continuous delivery and why it matters to so many businesses. Okay, so continuous integration, strictly speaking, means that developers working on a team, working on the same code base, are frequently integrating or merging their changes with other people's changes. The implication being there that they're all essentially merging or checking their code into the same branch. So they're not all working on their own long-lived branches, sometimes called feature branches or developer branches. They are merging their changes into the same branch. We often call it the main branch or the trunk. And they're doing that many times a day. Why would we do this? Well, there's a number of reasons. The first reason is, and the main reason, is to make sure that the changes we're making to the code don't conflict with changes other people are making to the code. The less often we merge our changes into the trunk branch, the more changes we make between each check-in, the more likely it is we're going to get merge conflicts. And teams who check in less frequently to the trunk branch tend to find that they spend a lot of time clearing up merge conflicts. They kind of end up in a sort of a merge hell if they do all their merges, for example, on a Friday afternoon, which is the worst time to do it. So the first reason we do continuous integration, or this trunk-based development, as some people call it, is so that we can test that our changes don't conflict with other people's changes. And the more often we do it, the less likely they are going to be merge conflicts, and the less time we're going to spend with our fixing broken builds. The second reason we do it, equally important in my opinion, is to frequently communicate the changes we're making with the rest of the team. So if there are other developers working on the same code base, and working in the same parts of the code, working on the same classes, we need to know, we need to keep ourselves up to date on what's changing. So if we check in infrequently, if we have, for example, feature branches that last for days or even weeks, then that's a bunch of stuff we're changing that nobody else knows about. And so I've seen some real train wrecks when people have started merging their code and realized that it just doesn't all fit together, basically. The jigsaw doesn't come together. So it's very, very important as a means of communicating to the team through code, this is exactly what's changed. So as well as, if you're using GitHub, for example, as well as pushing to the trunk branch on a frequent basis, many times a day, you need to be pulling on a frequent basis as well, and taking a look at what other people have changed, looking for conflicts, having those conversations if there's been some misunderstanding or something is going awry. So very important for that as well. And the final reason that it's important that we check in our code frequently to the main branch or the trunk is because the changes we're making on our desktop, maybe they work on our computer, but they're not in a state where they can actually be released for the end users. So the third reason we do it is to enable this thing called continuous delivery, which is to have our code always shippable. If it's sitting on my desktop or my laptop, it's not shippable. That's of no value to the end users. That's of no value to a business. So in order to enable continuous delivery, having code that is always shippable, we need to be checking our changes in on a frequent basis to the trunk branch, the branch from which those builds and releases are created. So that's why we do it, so that we can test for merge conflicts on a frequent basis and avoid that merge hell, so that we can communicate our changes on a frequent basis with the rest of the team, and so that we can make our changes shippable for end users if they want them. And a lot of teams do this or claim to be doing this. I've got some bad news for you if you're using long-lived branches like feature branches. By definition, if you're not frequently merging to the same branch as a team, you're not doing continuous integration, and therefore you can't be doing continuous delivery. So that's the first piece of bad news. The second piece of bad news is this doesn't come for free. There are a whole bunch of technical implications. The main one being, as well as sort of having to commit and push on a frequent basis, the main one being that whatever we're pushing to our GitHub repository, to our trunk branch, we need to be highly confident that we're not breaking the code. And that's where tests come in. If we've been doing TDD, for example, and been writing lots of really good unit tests, then we can use those to protect us against the risk of merging code to the trunk branch that breaks it, that doesn't actually work. So what we're going to do is we're going to demonstrate this process with two imaginary developers. There's Jason 1, that's me, and there's Jason 2, that's me. So I've got two copies of some code that Jason 1 and Jason 2 have both been working on independently on two different requirements, but there's some overlap between the code and between the concepts. So let's take a look at this code. As you can see here, it's for our CD warehouse. Jason 1, hello. I've been working on a functionality for searching the catalog for CDs, so search by artist and title. I've got a test passing here, so I've got some basic functionality, and I'm thinking this would be a good time to share this with the rest of the team. I've added some classes and made a few design decisions. It's time to let the team know, and also to test that it works in the shared code base. And Jason number 2, that's the second copy of the code here. I've been working on functionality for buying CDs. So I've got a little test running there, got a little bit of functionality. I've added some classes, made some design decisions, and I would like to share that with the rest of the team. And of course, make sure that it doesn't conflict with any of the changes they're making. So we're both at a state where we would like to check our changes in, but it's not quite as straightforward as me. I can't just do a git commit and push now, because I need to make sure that what I'm checking in isn't going to break what's in GitHub on our trunk branch. So I'm developing on the trunk branch here. We're both developing on the trunk branch. So what should I do before I even think about doing anything else, before I even think about committing? Well, first of all, let's take a look at our tests here. Let's make sure that we've got passing tests. So I'm going to run my test and make sure that it works. So make sure it works before you do anything. There's not much point if it's not. And then I'm going to commit that. Let's and give it a meaningful message. So I've added search catalog test. And okay, now at this point, you think, well, no, you just push it to GitHub, don't you? No, we don't do that at all. While I've been working, this is a shared code base, remember, it's like a shared database. Other people might have been pushing stuff to the trunk branch. So the next thing I'm going to do is just make sure that I am up to date. If there are any changes, I need to merge those changes into my code and then retest it just to make sure that what I'm pushing isn't going to break the build. Okay, so I'm confident that I'm up to date. There's no changes that other people have made. Jason 2's been busy, but he hasn't pushed anything yet. So now we're going to think about pushing this to the trunk. So this is the branch that Jason 1 and Jason 2 are both working on. We don't have our own branches. Okay, that's done. So that's in there, and I'm done, but we're not quite done yet, are we? There's a bit more to this. So I said about not breaking the build. Well, how do we know that I haven't broken the build? How do we know that what I've actually checked in, what I've merged into the trunk branch, hasn't broken the software? Remember, our goal here is to have software sitting in our GitHub repository on the trunk that is potentially shippable. So I want to get what's called a corroborated build. That is, I want to see it build and see the tests pass on a different machine, so we can rule out any local configuration differences that might be making it work on my PC, but wouldn't work in the target environment. So I'm using a cloud-based solution here called Circle CI, and what that does is whenever someone pushes to Git, it checks out that code, sets up an environment to run it on. So then we're spinning up the environment, preparing all the variables for that environment. We check out a copy of the code from GitHub, do a bunch of Python related stuff and a bunch of pip related stuff. And then finally, very importantly, we see that it does indeed work by running the tests at the end. And my test there is passing. So I've got a green build. And that gives me more confidence that what I've just checked into GitHub there has not broken anything. And that's very, very important that we need to, as you'll see, we've had a few failed builds as I set up my build there. But a green build essentially means that, yes, what you've just checked into GitHub now works. We've seen it build and we've seen the test pass on a different target machine. So we've got some confidence in that it is indeed shippable, if indeed the tests are any good, which is a whole other video that you might have seen about mutation testing. But there you go. So JSON 1 is now kind of done. We've got that green build, which means it is safe, and this is very important, it is safe for JSON number 2, hello there, to do his check-in, essentially. Now, what would have happened if while I was doing that whole process, so from running the tests and committing it, and then pulling and then potentially merging those changes into my local code, and then running the tests again, and then committing that if the tests all pass, but only if the tests all pass. If they don't, then we've got to fix that, obviously. And then pushing that to GitHub, and then waiting to see that what I've just pushed to the trunk actually builds and the tests pass on that build server on Circle CI. That whole transaction needs to, basically it succeeds or fails as a whole. For example, if in the process of doing that, I've broken the build, and while we're waiting to get our corroborated build, JSON number 2 checks in on top of me, I'm now checking in on a broken build. I'm checking into a broken code base. So that's a very bad thing indeed. On top of which, it may be that I've made some changes that will conflict with the changes that JSON number 1, hello, has just checked in or is about to check in. Remember, it's a whole transaction from deciding that you want to check in to actually seeing that build go green on your continuous integration server, on your build server. That's a single transaction. And the danger is, particularly on larger teams or also on distributed teams, so if you're working from home at the moment, you might want to think about this. The danger is of having people checking in on top of each other and essentially breaking the build unwittingly by introducing conflicting changes before we've actually seen the result of that first check-in. And I've seen that happen many times. So you need maybe a simple way of locking your version control system, locking the repository on GitHub or whatever you're using, to try and prevent other people from checking in while you're waiting for your corroborated build, while you're going through that process. And one thing I've seen teams do is they've introduced what's called a build token. And that's just, if you're in a real office, that's just some very recognizable object. Or if you're all on webcams, like a hat, for example, a silly hat, and it lives in its own place in the office where everyone can see it. And when you want to check in your changes, you go and get the hat or whatever your build token is. Like, could be a hat, could be a rubber chicken, something that looks out of place and is visible from a distance. So if anyone's wondering, well, who's checking in at the moment, they can look around the room or they can look up people's webcams. So you could probably do something similar with Slack or have some kind of system. So this is on larger teams in particular, there's a greater risk of this. So JSON number 2 is going to be a good continuous integrator, and I'm going to put on the hat. And that hat, because I have the hat, nobody else is allowed to check in. This is like a lock on a record in a database. Nobody else is allowed to update the repository while I'm wearing the hat. So I'm locking it now, and we're going to go through this whole transaction again. It's going to be slightly different for JSON number 2 because we now know that there are changes that have been made to the code base. So again, first thing I'm going to do before I do anything else is just see the tests pass. No point in even thinking about checking in if they're not passing. Now let's get that committed locally. So I've added by CD test. Okay. So I'm all backed up locally. I've got my seat belts on if anything goes wrong when I do this merge. So again, before thinking about checking in, let's just make sure that we're up to date. IGIT, I think, is not the right word. So let's just pull from the trunk. Okay, so there's a bunch of stuff that's happened here, and we have indeed, it's telling us we've got some merge conflicts, as I would have expected in the compact disk class, because we both created a compact disk class at the same time. So that's why we want to merge on a frequent basis, because let's take a look and see what it looks like. Okay, so we've essentially got two different initializers, two different constructors here. And we need to think potentially about merging these. So what I'm going to do is I'm going to add artist and title to the constructor here for our CD. And we're going to add in setting of the fields. Let's put them in order. So let's do that first. Okay. And then we can get rid of that, all the merge annotation stuff here. And there we go. Hopefully what we've got now is something that will work for both of us. And you can see that a bunch of stuff that was deleted has also gone as well. So when I was setting up my build, and this is a good tip, if you're setting up continuous integration servers, create a dummy test. So create an empty project with the tech stack that you want. So in this case, just vanilla Python. And then create a dummy test, see and make sure that test actually runs. An easy way to do that as you're setting up your build is make sure the test fails and see it fail. So just check that the test is actually being run. A number of times I've had teams who've had a build that looks green, but the reason it's green, the reason the build is succeeding is because it's not actually running any of the tests. So make sure that you don't get into that situation. So we've got a bunch of tests here. Let's run them all. Okay. That's interesting. What have we got happening there? Some nose test stuff. I need to rewrite my test. That's why we have tests. So here, we need to say, okay, there's an artist and title. It doesn't actually matter what they are. If we're buying a CD, that's not important. And in our test for search in the catalog, we need to provide a price. It doesn't matter what the price is. We need a price for stock. It doesn't matter what the stock is. And we need, well, payment. So is it null? Or is it, I'm a bit Python, nothing. I can't remember how you do null in Python. This is a good demonstration. But excuse me while I just quickly Google. I'm getting my Python head back on this week. Python null. None. There you go. So just so you know, this is live. It's not edited. Okay. So this can be none because we only need the payments object if we're actually going to buy the CD, and we don't need that for this test. So let's try running those tests again. So this is why I'm wearing the hat. While all of this is going on, there's a real danger. The longer it goes on, the greater the danger. There's a real danger that someone else is going to check in underneath me now. So I'm stuck in a bit of a loop here. So let's rerun the test. Let's make sure we're good to go. Tests are passing. Perfect. So now we commit this. This is the definitive version, if you like. This is what's going to end up theoretically in GitHub on the trunk branch. So let's so merged JSON number 1 changes. Okay, now I'm going to push to the trunk. And yes, I have renamed my master branch, in case you're wondering. That's I think that's the right thing to do these days. So let's push that. And then immediately while that's happening, I'm going to go take a look at our build status page on Circle CI here. There are other continuous integration solutions available, including your own if you want to set up your own machine. So it's going to run that, and then hopefully, there we go, we've got a successful build. Now, let's just make double sure how many tests were run. So I'm checking this, not maybe on every check-in, but I check on a frequent basis. Are the tests actually being run? And indeed they are. That means that what we've got in our GitHub repository on the trunk branch here, let's take a look at that, and let's just refresh that. What we've got now is the definitive code, if you like, and because it builds and the tests pass, it is essentially shippable. If the customer said, okay, give me that now, we've got something we can ship straight away. And that leads us into, I should take the hat off now because I'm blocking the rest of the team. That leads us into the whole conversation about continuous delivery. Talking of blocking the team, what happens if you break the build? Whose problem is that? Well, if you think about it, if even if they're not actually wearing the hat, there's a kind of a theoretical hat in the sense that if you break the build, nobody else should be checking in, which means you're blocking everybody else's delivery. You're basically a blockage in the delivery pipeline, if you like. So it's the team's problem. So if you do break the build, you need to fix it as quickly as you can. And really, if the team needs to pitch in and help that to happen, then so be it, because they're all now blocked. I would seriously consider, if you can't immediately see the problem, actually rolling it back. So whatever changes you've merged, roll them back to the previous working version, see that version work, and then other people on the team can put on the theoretical hat and they can do their check-ins and you're not blocking them anymore. So this is all about not breaking the build for all sorts of reasons, partly because you're blocking the team, but also because you want to make sure that what you've got in GitHub is actually shippable. So let's talk a little bit about continuous delivery. Continuous delivery doesn't necessarily mean that we're continuously or frequently releasing our code to end users or to some target environment, but it does mean that at any point in time it could be released. In other words, our software is always shippable, and that means it must always be working. So the discipline for continuous delivery at our end as developers is to make sure that it's always working. And that's a very powerful thing because it means customers can have software and changes to software whenever they need it. So rather than, for example, having to wait 6 months for a big release to get one change that marketing really needed 6 months ago, they can have it as soon as that change is ready. So those delivery cycles get much faster, and the feedback loops from delivery get much faster. We learn much faster from giving real working software to real end users than we do if we're releasing every 3 months or 6 months or even every 2 weeks. You could be releasing as often as you need to. And that's really the point of it. It puts the customer in the driving seat. They press the button and they can press the button whenever they like. I've worked in many places where the customer says, can we have that now? And we're like, well, there's the 6 weeks of acceptance testing and then there's all the bug fixing. And so an implication of continuous delivery is that your code is always working, which means you must be continuously testing it and continuously merging the code. So not just testing it on your machine, but testing that it actually works, that whatever you're checking in to GitHub, the shared code base, that actually is working, that it's shippable. So a lot of implications there, a lot of skills involved, a lot of discipline involved, individual developers and team disciplines, for example, your build tokens and all that kind of stuff. But it's very, very important to get it right. Very, very important to get it right. But that's not where the story ends. A lot of developers have kind of blinkers on where they don't really see beyond they don't see beyond this. They don't see beyond the green build. I've got a green build. My job is done. My job here is done. Well, that's not really what it's all about. In order for software to be always shippable, kind of implies that the pipeline doesn't stop at GitHub and it doesn't stop at the build server. There's more of the pipeline. Now, on the third day of the Codemanship Codecraft course, which of course I highly recommend for teams, we do an exercise called Evil Fizzbuzz. And essentially, the group have to work together as a team on a very simple program. So they have to deliver a simple working program, but they have to do it as a team. So they're only allowed to work on their small bit. And of course, that makes it a lot more complicated and a lot more difficult. And I make it very, very clear at the start of the exercise that the goal is to deliver the Fizzbuzz program to be able to demonstrate that working on this laptop. This is quite an old, underpowered Lenovo laptop. And I say, look, by the end of the hour, I need to see it working on here. That's the goal. And so groups and teams generally do is they, first of all, they have lots and lots of arguments for the first 20 minutes about how they're going to do it and whether they're going to do it in Python or are they going to do Django, is it going to be plain Python, whatever. And then someone goes away and starts working on, they set up a GitHub repository. They invite all of their teammates to collaborate on that project. And that usually takes a while as well. And then they set up a continuous integration server, so they shave all the acts to get it building and testing and all of that. And they get about 40 minutes, 50 minutes into a 1 hour exercise. And at the end of that, 50 minutes in, someone says, oh, by the way, Jason, do you have Python installed on that laptop? They start to ask questions about the end result, which is the delivered working software in the target environment at the end. And that, here's a pro tip for developers and teams. You need to flip that around. If it works for TDD, it certainly works for continuous delivery. Start with the end result. Where does the software need to be? How does it need to work? And work your way backwards, creating a delivery pipeline that will include version control and building and testing on something like Circle CI or your own service. But more importantly, has a fast, reliable, automated route from this green build to the target environment, whether it's a smartphone or whether it's a server or whether it's Docker or whatever it is. Start there and work backwards. So what I recommend teams do when I'm coaching them in this is to start by making Hello World appear using their target technology stack. So it could just be a command line application, for example, but I want to see Hello World on here, make that happen, and then start talking about the problem you're actually trying to solve. So get that delivery pipeline all worked out. It's very important. Teams that do this well are real assets to their business because the ability to ship code or to be confident that you can ship code on a very frequent basis is some very powerful stuff. All sorts of things become possible. And one of the things that becomes possible is you can start to let go a bit of that kind of analysis paralysis, that fear of building the wrong thing. Because if, for example, you get to throw the dice again and again and again and again, it's less of a big deal if it's not quite what the customer really needed. And I've watched teams try and sort of specify the whole thing up front and get the requirements exactly right. And I've watched teams kind of iterate their way towards it, just deliver. And I know which one of those tends to work best, and that's the iterative approach, which is why I keep maintaining that iterating or iterative delivery of software is the real requirements discipline. Take your best guess, deliver something quickly, fail fast, as they say, learn some lessons, and then go round again. And that's only really possible if going round is not a 6-month cycle. If it's a 6-day cycle, that's much better. If it's a 6-hour cycle, that's really good. If it's a 6-minute cycle, then we're really powering. Now, remember, this is not about necessarily releasing the software every 10 minutes to end users. That's going to probably annoy them quite a lot. It's about putting the customer in the driving seat so they can release it whenever they want. Now, I'm going to end with one more thought about continuous integration. So I mentioned at the beginning that if you're developing on long-lived branches, for example, feature branches, by definition, you are not doing continuous integration, which means you cannot be doing continuous delivery, which means you will not be getting the benefits of that to anywhere near the same extent. And a lot of developers say, yeah, but if we're all checking our changes in, these are all unfinished features, what's going to prevent us from releasing software with unfinished features? What's going to prevent our users from driving over a half-finished bridge, as it were? Well, there is an alternative here. There is a way that we can have our cake and eat it. There is a way that we can hide unfinished features, unfinished code from end users, and get all the benefits of trunk-based development, of continuous integration. And that would be to use what are called feature flags, or sometimes referred to as feature toggles. And essentially, a feature toggle is just a simple way of switching features on and off. And usually it's something we would put in the hands of our customers. So it could be just as straightforward as a text file with simple on-off values. So this feature equals on, this feature equals off. Or you could do something more sophisticated and give the customer sort of a dashboard where they can switch features on and off. Architecturally, it's quite straightforward to do. For example, there are all sorts of simple design patterns like the command pattern, or UI patterns for hiding things that users aren't supposed to see, to make, for example, menu items visible or invisible, depending on whether it's switched on or off. So these are relatively straightforward to do. Architecturally, they can have other uses as well as switching features on and off. So you might want to consider taking a look at feature flags or feature toggles as an alternative to working on these long-lived branches, so that you can essentially have your cake and eat it. So there you go. That's continuous integration, which leads to, it's the doorway to continuous delivery, which is the doorway to learning faster, essentially out-learning the competition. It is a very powerful and valuable thing for a business to be able to achieve. There really aren't, in reality, that many teams and that many organizations that are truly doing it. A lot of long-lived branches out there, for example. There's a considerable investment in skills. There's a considerable investment required in automation and infrastructure. And there are a lot of organizations who are not willing to make that investment. So they live with the consequences of slow feedback cycles. In the next video, we're going to talk about the testing pyramid. That's all about how fast our tests run. And you may be beginning to get a sense that that's quite a critical metric in your delivery cycle. So the next the next video is going to lead on directly from this, about the testing pyramid and about how we architect and organize and optimize our test suites so they run as fast as possible.